Welcome to a new test and teardown video. This time we're going to play with an oscilloscope again. This one is from Hitachi V-212. It's a dual channel oscilloscope capable of handling 20 megahertz. This one is in what I would call brand new condition. I don't know if you can see this on the video, how nice and beautiful it looks. I mean, this is not even mint condition, but new condition. Wow, look at that. I don't even dare to touch the knobs to get them dirty. Oh. I really hope it works. How about we just power it up and see what happens? So let's power this thing on. Mains is applied. There's nope, we survived. LED is on. 22 watts. And that is about what it is. We need to warm up the tube a little bit. Yep, oops, we got light. Focus needs to be all the way to the right. That is a little bit odd. So this is the position. Okay. So far, so good. This is not that channel. Nope. Okay. That is not what I expected. Why is it not responding to this? That is not so good. So it is defect. It seems like the time-based stuff is working, right? Oops. It's also responding to alternating chop. Okay, we see some. No. Okay, we got ourselves a defect scope. Always a lot of fun to see what works on from the front plate, right? So let's look at this. Tricking is working. So now I'm in normal mode, and now I go trigger to channel 2 and plug in something on channel 2 and see. So trigger is working, and it's also responding to the level. And what if I go, how about this one? So all trigger inputs seems to be working, but we got ourselves a completely flatlined scope. It's not even responding to this. So this is the thing, look at that. We need to open and see what is wrong here. Hey, I was so happy, this was so beautiful, and then, hey, it's not working. Well, that is of course why I got the damn thing. So we are inside this beautiful oscilloscope, and we got two PCBs, two really big PCBs in here, and I believe all the top stuff we see here is related to time base and sweep and trick and all that stuff, and that is working. So I mean, we're not going to find the bug on the time base and sweep and trick and whatever this board is doing, right? And in here I think we got the high voltage. See, high voltage is extra isolated, and They even say, ooh, danger, high voltage and whatnot. Well, that is definitely why we want to look in there. What is in there? Haha. Yeah, let's have a look. While we're looking at this side anyway. Boring. Is that all? So this is the transformer for the high voltage. Look at that. We got some funny high voltage diodes, and only one is populated. It's because they can do with another diode, they can do a tripler or something, and they don't want to do that or something like that, right? And that will be the flyback transistor for the high voltage. But that works. We got picture anyway, so we don't need to worry about that little box here. And here we go. This will be the two analog inputs and the attenuators. Got some AC DC switches and stuff, and then input goes here. Got a little op amps and some transistors and stuff. But since we know it is responding to the input and the trick is working, so that means all this stuff is most likely working all the way, right? And there's not a single blip or blob or offset or anything is happening. We only got a flat horizontal line. So what is this? This is vertical deflection going to the tube. I'm saying that there's exactly the same voltage on these two because this system here is not working. It's either the amplifier itself, supply voltage to it, or input to it that is missing. So this is where we want to find the bug. So we just need to see if we can figure out how this works. We got some input. Is this input or what is that really? We got, this will probably be all the supply voltages for all this stuff. It looks like this amplifier was running quite warm. I do expect this to be normal because also you can see the big heat sinks, and they need to be really fast, so they will be biased really hard, and also there will be a lot of voltage over those transistors because this is how static deflection works, high voltage. And you can also see this high impedance feeder here. That is because of the high speed. So now I'm going to measure a little bit around in this area and see what happens. So here is the vertical amplifier. I've been measuring a little bit around in this circuit. What I started to do was to measure the input. So this is the input, and those are the two first amplifiers. And then we look here at the schematic. So that is the input connector, and so all is super normal here. And look at that, really good schematic with voltages and whatnot. And what you see here is the amplifier itself with all the measured voltages I measured around in this circuit. And with those DC voltages, I was it was really easy and fast to find the error. So can you find the error just from the DC voltages I got here? Yes, you can. Look at that transistor in the middle of the picture. Same voltage on the base and the emitter. So it's shorted, right? So now I'm trying to get this board out. And it appeared to be quite easy in the beginning. And then I remove all the knobs here, and some of them don't really get out. I think maybe there's another little piece of metal in here, and some of the pots that are connected to that, and now I need to Pull the whole thing completely to pieces. That was not what I expected. I was hoping this to be super easy. Oh yeah, by the way, again, let's look at this schematic. It says V-212. That is this model. Yep. And look again, the shorted transistor here is TR371, and it's supposed to be a 2901. Look at that one, TR365, and that is supposed to be a 2901. So what I'm doing is I checked out this transistor here. That one is the 2901, and that one is TR371. I don't know if you can see this. And that is a big bad boy on the heatsink, and that is the one that is shorted. So this cannot be a 2901. Duh. So what I found out in the manual, I went to the next model, the 222. That one got a completely different transistor exactly at that location, and that is this big one. So what they're doing is they're mixing schematics and stuff like that. So this is not the right, probably not the right board for this model. Funny, isn't it? Confusion. It is an IQ test of the most difficult to figure out how you disassemble this damn thing. Behind the logo here, there are two screws. Then you take off the screen plastic. Let me show you guys this one. See those two screws down here? That will let you take off this, so you can clean this and whatnot. And then you can access those two screws. Ooh, and with this other screws around here and stuff, now you can take off this piece of plastic. Yeah, and then you should be able to take away this piece of metal. Yeah, and then finally we're gonna get to those screws here. The nuts down there. That will let me access this board. Oh my god, difficult, yeah? So that was difficult. But anyway, it's out, and you don't need to remove those two nuts. But the rest, of course, you need to pull this and remove all, and then you can pull out the board just like this. I didn't even disconnect any connectors, so no need to do that. And now you can flip-flop the PCB and do the service on that transistor. And obviously, when stuff is running really warm, as you can see, it's revealed by the color. Yeah, you will get really short lifetime, and I expect it is this TR371 that is shorted, and this is of course something I want to prove. And it is out, and it was of course a 2912. So if my idea is right, we should see some two diodes. Yeah, okay, I got it. It's because it's the two pins on the sides, pin 1 and 3. Those are shorted, right? So that is how it is. Let's remove all this pile of what have you. Yeah, you see what I'm saying? It is of course shorted. Haha! So what I'm saying is this was not lock, but just measurements and super easy, right? Anybody could do this. I cleaned this area nice and clean with acetone and those cotton buds, so it's really nice and clean. I think the old flux overheated over like 30 years, made this bad spot of, I don't know, vapors that kind of got into the plastic. I cannot clean this away. So Now we're gonna try with a new transistor, and less than 20 hours later, look what shows up. All I have to do is just ask my sponsors and supporters, and then I get free stuff. It's that easy. So now the new transistor is in. I actually only put in one new one. Of course, I'm going to change both of them, and it's a balanced stage and all that, but let's just see what happens. Are we going to see a lot of smoke? Or are we going to see a lot of happiness? I don't know yet. I got the finger on the button. Ready. Why don't we see anything here? That is a little bit confusing. Hello. Ah, yeah, okay, it's my fault. So this is the... Yeah. Look at that. Winner. Chicken dinner. Let's... Where's the brightness one? Oh, okay, I've pulled out all those. So we're not going to get a lot of brightness, but let's input some signal. Look at that. Oh man, I need some brightness, and I need some trigger, and I need some... But anyway, the damn thing is working so far. So I had to put in the PCB so it's easier to play with. Now I could also stick in the buttons for the brightness. And as you can see now, this will be focus. It's that one. So now that one is nicely in the middle. And this is exactly what revealed we had a problem with deflection and a missing or the correct point of voltage for the deflection plates. They're just fully to the plus rail, right? So that is of course why focus was not correctly in the middle as well. So yeah, we could really see everything from the front panel. However, now trigger is not working. So there's probably a connector that fell out or something that is not working anymore, because I don't seem to have a trigger. I actually don't know exactly what is causing this. And so this is the trigger, and it's not responding to anything. And it should be internal trigger, and I just could say channel 1, and that is channel 1. And this is my different modes. It's so the channel 1, channel 2, both of them in alternating on chop, and then add. So that means, yep, it's affected by both of them. So all that works. You see all the funny DC stuff is now correct. So I'm super happy about the repair of that, but trigger is not working anymore. Damn it. This is the trigger circuit. This is the IC that is doing the tricking. It seems like this IC is not working, so what I did is I changed it, put it in a new one, and you know what? This IC is not working either. Oh, you're not going to believe this. Can you see this dotted line down there on the PCB? I don't know why this shit is not in focus. See, there's a dotted line after pin 7 to ground. This is a via, or this is a jumper that gives this IC ground connection. That jumper here is not mounted. And if you look at all the other dotted lines on this PCB, you'll see there is a connection in here, right? So this IC is not getting ground, and that is why this scope is not working. That means this scope has never ever worked, and nobody complained, nobody sent it back, and this is why this scope looks absolutely new and shiny and fine. It was never ever working. My God, I bet if I put in this connection, I'll get 5 volt to this, because I got 5 volt on its positive side, but I got like 2.5 volts like jumping and shitty here on pin 7. And if I look at all the other ICs nearby, they got 5 volt exactly as they're supposed to. My goodness, this is interesting. You are not going to believe this. Installing this missing jumper right there. That one. Now I got voltage on my NAND gate. And actually the one that I put in was pulled out from some other old junk, and it actually turned out not to work. So the original is back in the socket. And what do you know? Let's look at this beautiful, beautiful scope. See, this is the trigger. See, I can adjust the point, and if I'm not at the trig, I am in auto, and now I'm in normal, so that means I need trig for this to work. Oh, look at that, and the picture is just absolutely beautiful. So yeah, I'm super happy now. The scope is completely restored and repaired, and I had 2 faults. One was actually a manufacturer fault. What do you know? I've never ever seen anything like this. And this scope is 30 years old and nobody complained. But look how new it looks. Nobody ever used this scope. It was just put on a shelf to rot. But how do you explain the vertical amplifier being this dark and black and burned out? So they use this scope, but how can they use it when this trigger is not working? I don't get it. This trigger was never ever working in this scope.